watching this video until the end. Good day everyone. Let me introduce myself first. My name is Nicolaus. For this video, I'm going to share with you about the history of our solar system. The solar system is the gravitationally bound system of the Sun and the objects that orbit it, either directly or indirectly. Of the objects that orbit the Sun directly, the largest are the 8 planets, with the remainder being her smaller objects. The dwarf planets and the small solar system bodies of the objects that orbit the Sun indirectly. The natural satellites, too, are larger than the smallest planets, Mercury, and one more almost equals in its size. The solar system formed 4.6 billion years ago from the gravitational collapse of a giant interstellar molecular cloud. The vast majority of the system mass in the Sun, with the majority of remaining mass contained in Jupiter. The 4 smaller inner system planets, Mercury, Venus, Earth, and Mars, are terrestrial planets. Being primarily composed of rock and metal, the 4 outer system planets are giant planets. Being substantially more massive than the terrestrials, the 2 largest planets, Jupiter and Saturn, are gas giants. Being composed mainly of hydrogen and helium, the 2 outermost planets, Uranus and Neptune, are ice giants. Being composed mostly of substances with relatively high melting points compared with hydrogen and helium, called volatiles, such as water, ammonia, and methane. All 8 planets have almost circular orbits that lie within a nearly flat disk called the ecliptic. The solar system also contains smaller objects. The asteroid belt, that lies between the orbits of Mars and Jupiter, mostly contains objects composed like the terrestrial planets of rock and metal. Beyond Neptune's orbit lie the Kuiper belt and scatter disk, which are populations of trans-Neptunian objects, composed mostly of ice, and beyond them a newly discovered population of cenoids. Within these populations, some objects are large enough to have grounded under their own gravity, though there is a considerable debate as to how many there will prove to be. Such objects are categorized as dwarf planets. Astronomers generally accept at least 9 objects as dwarf planets, the asteroid series, and the trans-Neptunian objects, Pluto, Eris, Haumea, Makemake, Gonggong, Quaoar, Sedna, and Orcos. In addition to these 2 regions, various other small body populations, including comets, centaurs, and interplanetary dust clouds, freely travel between regions. 6 of the planets, the 6 largest possible dwarf planets, and many of the smaller bodies are orbited by natural satellites, usually termed moons after the Moon. Each of the outer planets is encircled by planetary rings of dust and other small objects. The solar wind and a stream of charged particles flowing outwards from the Sun creates a bubble-like region in the interstellar medium known as the heliosphere. The heliopause is the point at which pressure from the solar wind is equal to the opposing pressure of the interstellar medium. It extends out to the edge of the scatter disk. The Oort cloud, which is thought to be a source for long-period comets, may also exist at a distance roughly 1,000 times farther than heliosphere. The solar system is located at 26,000 light-years from the center of the Milky Way galaxy in the Orion arm, which contains most of the visible stars in the night sky. The nearest stars are within a so-called local bubble, with the closest PROXIMA Centauri at 4.25 light-years. The main idea of the solar system was proposed by the Polish astronomer Nicolaus Copernicus, 1473 to 1543, who said that the Sun is the center of the universe and the maid of the planets moved around it in a perfect circles. In his book entitled On the Revolution of the Celestial Spheres, written in Latin and published in 1543. The Sun, Moon, and brightest planets were visible to the naked eyes of ancient astronomers, and their observations and calculations of the movements of these bodies gave rise to the science of astronomy. Today, the amount of information on the motion's properties and compositions of the planets and smaller bodies has grown to immense proportions, and the range of observational instruments has extended far beyond the solar system to the other galaxies and the edge of the known universe. Yet, the solar system and its immediate outer boundary still represent the limit of our physical reach, and they remain the core of our theoretical understanding of the cosmos as well. Earth-launched space probes and landers have gathered data on planets, moons, asteroids, and other bodies, and this data has been added to the measurements collected with telescopes and other instruments from below and above Earth, the atmosphere, and the information extracted from meteorites and from moon rocks returned by astronauts. All this information is scrutinized in attempts to understand in detail the origin and evolution of the solar system, a goal toward which astronomers continue to make great strides. And I'm hoping, guys, that you learn something with this video, guys, about the history of the solar system.